meantime, we can check who is a Maven user. Okay, and who is a Gradle user is here to collect trash on Maven? Okay, very good. I can see that. You're welcome. Great that you're here. This is the talk Apache Maven Survival Guide. Bring it on, Moan. No external tools. Why no external tools? Because the reality that we face when we are out at clients, sometimes we have a good situation where we can install things. Often we have a situation where we can do nothing with the system, so we are not allowed to install things, so we had to learn to get by without any external tools. And that's what we try to do in this talk. So everything that I showed today has like no dependencies that you have to buy, so you don't have to get a budget for it. And on the other hand, you don't have to talk to operations, which nobody likes, yes? So, okay, this is what the talk is going to be. We have a lot of live coding, only a few slides. We will do it in a computer game style. We have level 1. We add some tests and make them run. And we have a little bonus level there where we make the build reproducible. Then we have level 2 where we add some dependencies. And then, of course, we check if we really need them. We will secure our project. Security is a big concern for most people. Then we will save time, money, and if you like the planet. So I have kids, so I like saving the planet. And I like to go around, say I take an airplane to a different country and I save the planet. So I have to compensate with this talk for my CO2. And then we have to do some paperwork, of course, because that's all the fun, right? So I will show you how to do the paperwork with some fun. Give a little introduction so you know where the experience or the opinions that I have come from. And I know that there will be different opinions, and I would like to hear them best after the talk. So my name is Richard. I'm a JUG leader in Germany, and I do a conference. Been in the software industry for about 20 years, and we do Rapid Clips, which is a IDE for Java. We've been doing IDEs for 20 years now, and it helps you to build nice web applications with drag and drop. So you can bring your colleagues who don't know Java, and in the end it's just Eclipse and you can write code. So you have a very smooth transition from drag and dropping things and having a nice UI to have a Java project. And that's where our experience, or my experience, comes from with Maven, because we deal with a lot of people that are new to the Java ecosystem, and they come from platforms like FileMaker or FoxPro or things like that where they don't have Maven. And we give away all of our tools for free, so I need to advertise a little bit. So if you need help with Java or you want to have hear some dumb jokes, please let me know, and you can give me money for that. So let's start the talk and the content. It's only 5 slides, and then we will go to the console and do some live coding. So what is Maven? And if you don't know him, this is Ron, is the like the mascot of Maven, and he's not always that aggressive, but it's a nice Star Trek reference, and I couldn't leave it out. So Maven is a build tool and a dependency management, and it's always the best when things do 2 things, right? Okay, separation of concerns would be better, and we will get a better experience for that in Maven 4 and Maven 5, where there will be a better distinction between the build tool aspect and the dependency management aspect, because the dependency management aspect is also relevant for people that use Gradle, because they also use the dependency management information from Maven universe. So you need to know a few things before we can start. One thing is you have a super POM, which is in the Apache Maven runtime. So you get that when you install Maven. And then you have your POM, and there could be parent POMs and stuff like that between. But in the end, you have a POM, and this usually ends up in your version control system. And we will talk about this in a minute. So when you're working with your team on a project, the POM that you use that is in your version control system, in your Git, is usually the same that is shared, but the super POM that is installed on your machine that could differ from colleague to colleague that you have. Like the one guy could have it version 3.6 on his machine, and your colleague, she can have Maven 3.9 or something. And you wouldn't notice it because Maven is very stable and very backward compatible. And so you just, do you even know which Maven version you run? Who knows which Maven version they are running? Okay, that's like 10% or so, okay? As you can see, this is a good place to be in, right? I don't even know what version it is. Okay, good. Then we have, of course, lifecycle phases, and these are all boring. But we got to talk about this one. We got Maven Verify. And we got to thank Andres Elmrei for like making 100,000 memes about this. And who has seen this controversy about Maven clean install, Maven verify? Okay, a few people. Okay, you should be more on Twitter, but okay, again, nobody's on Twitter anymore. Okay, thanks, Andreas. But we will talk about this because there is a controversy about if you should do Maven install, clean verify, and we will see what's the right way to do it. Okay, and then of course, we have to talk about, so verify is only running your checks, integration tests. Install is doing one more thing, so it's copying your artifact that you built and tested to your local Maven repository. So we will see how much of an impact that is to your build time. And then we will have Maven deploy, which is unfortunately named, in my opinion, because I think when people use it, they tend to think that it means I deploy to a staging system or production system, but it usually is not the case. You could like make it so that it does, but it just means transfer my artifact to a Nexus or a Artifactory or to some other Maven repository. And this does not mean it's automatically rolled out somewhere. Of course, you can have pipelines and everything, but the Maven part is just copy it to a remote location. And then there is the last thing you have to know before we go into live coding. There is two classes of dependencies you can have. You can have your code up here, and it depends on Jasper reports and the cache library. So you are actually using classes from these artifacts in your code. And then Jasper reports brings a PDF library and barcode library, but you may never use the barcode or PDF library in your actual code. This is just something Jasper reports needs to do its job. And so we call this first hierarchy, we call this direct dependencies, and then below that, that is transitive dependencies. This is going to be important in the live coding. And this is what we're going to start right now. You don't have to write anything down or take any pictures, because everything I do, all the commands that I type will be on GitHub, and also every step that I do in this talk is a Git commit in my repo. So you can go through all the commits and see what I did and see how it works in your machine. Okay, let's switch. Is this big enough for everybody to read? Yeah, okay, thumbs up from the back, that's always good. So we will start out here, and I have a second monitor which I will use to cheat a little bit so you don't see me type all the time. And I will set that up in a second. Okay, and we're good to go. So first thing we're gonna do is we're gonna look at what I've prepared for you. I have a very simple project, and it's small, and I recognize that most of you will have bigger projects. Who is working on microservices, small projects? Okay, third, and who is working on monolithic applications that have a few thousand classes? Okay, more people, that's good. Okay, it's good to see you're living in the real world. So, and then I will start this with Java 8 because I want this talk to be inclusive, and I know not everybody is on Java 21. Who is on Java 8? Okay, this is for you. Who is on Java 11? Okay, 17? Oh, good job, Sweden. Okay, 21? Okay. Okay, you're pretty current, that's good. Okay, everything that I show works, of course, with a new Java version, and I encourage you to use the most current Java version you can use, because it gets better. But I wanted to show for everybody that's in the audience that it also works with older Java versions, but in the end it will make no difference, just if you're wondering. And then we have a very good demo class, which is super fun and does great work, okay? This is what we're gonna start off, and we're gonna evolve this project to make it more complex. So first off, we will try to, of course, we'll try to build this. And what I'm gonna do is, until we figure it out, I will do Maven clean, or I've done clean before, I will do Maven verify. And I will see if this builds. And when you do some measurements, you should always take the time and see if your notebook is plugged in. Because I tried to prove a point and the notebook was not plugged in. And so the CPU has not that much power and I got very wrong readings and I got in a bad argument. And it's always bad when they say you plug in your notebook. So, okay, this being cleared, this works, so everything is green. The build took 2 seconds, so this is pretty acceptable. So we will start to add stuff, okay? And before we add stuff, we have to see something, because as you can see, this is not much that is going on. So I just said I want Java version 8, and I didn't tell Maven anything, and it just worked. So this is oh, I forgot the words. Convention, thank you. Convention over a configuration. So if you do nothing, it just works. And I wanted to show you where the magic is hidden. So you can have one command that is that will show you the effective pom. And effective pom means it combines everything that can be inherited, and it can be done with the command maven help effective pom. And if you run this, you can see what you get from the Maven runtime, and as you can see, there is a lot of stuff going on. So this XML file is huge, and you got a lot of stuff that is pre-configured for you. And this is a merge from like the super pom from your runtime, then parent poms that you might have, and then your actual pom. Okay, and we will start adding stuff. So the first thing we want to add is, of course, we need some tests because we are good developers. So for the tests, we add a dependency for JUnit. So we can use JUnit, and then, of course, our demo code does not change. And we wrote a little test class that I will open up. And this little test class is super convenient. Oh, that's the wrong one. That's the wrong one. This is super good. It has a very good test. So everybody should have these tests, okay? So people do this usually to get better metrics. When there is a metric for how many tests do you have, this helps a lot. So, and we want to run this, of course. So let's run this one. We also do Maven verify and have a look what will be the result. Okay. The one thing that nags me here about the result is that I don't get info in front of the line. So this is not nice. So this looks like broken. And then I have run test 0, which is not good because I clearly had a test. So, and this is a simple thing to solve, but I wanted to show you with this example how to solve problems in Maven in general. So if something is not working, it might have to do with that you have not the right version for it. So we should take a look what we can upgrade, and we will do this here. You can run a nice command which tells you what to upgrade. And we made a little change in the meantime here. So I put in the Maven Enforcer plugin, which is always a good idea to have. So this is just a plugin that enforces some things on your build. So you can say, hey, I want to have at least that and that Java version, and at least this and that Maven version, and a lot of other different things that you can enforce. So this is good. This helps me a little bit because this helps here when I run this command, versions plugin display plugin updates. And when I do this, it tells me, oh, what you're doing here, you've got the Enforcer plugin in now, and it has not the right, the latest version. There are updates. You could update this. I get no message about testing or there's something not working because it was not explicitly specified in my POM. So I will do that because I somehow have a hinge that it has something to do with the Surefire plugin that runs my tests. So I will do that and have a look at my POM. And when I look here, I added the Surefire plugin, and I took just a random number. This is a nice version number, so I used this one. And when I run this again, I can see that it will tell me that I could upgrade, I hope. Now you can see, oh, okay, I'm using the Surefire plugin and there is an update for it, and I should maybe update. But as this is a demo, I know that this version will be enough to run my tests. And if you were asking yourself, should I always go to the latest version? I would say basically yes, but check if it breaks something. It's usually a good idea to be on one of the more current versions. So let's see if this works now. I will do Maven verify again and see if my build runs. And now it looks better because we have this nice indentation here with info and we have one test that is run. So this is perfect. So this is the general idea how to fix problems in your Maven build. See if the plugins that are running, are they in the Maven POM, and then see if there's any updates to it. So we can go a bit further and do more plugins here. So I mentioned every plugin explicitly that I'm gonna use in this build. And you can say, oh, there's a lot of stuff to put in my POM, but it has a reason. The reason is it makes your build reproducible. So let's imagine you don't have all the plugins specified. So you will get plugin versions from the runtime that is installed on your machine. Your colleague, she may have a different version of Maven and will have different Maven plugins. So you want to produce the same artifact. This could go well or not, depending on what plugins are used. So, and with this, we make it very explicit and check it into our Git repo that we want to use these plugins. And now the build is reproducible because if somebody changes here to another version, they will check it into the Git repo, and next time you build, you will get the same result. And then when you have to fix a bug, like from 4 weeks ago, and you have to roll it out to production, you will be sure that it's as close as possible to what you've built before. Okay, we reached level 1. We added some tests, made them run. We solved the problem in Maven, and then we made our build reproducible in the way that we put all of our plugins in here. So the next thing we're gonna do is level 2. We add some more dependencies. And one more thing that I like to mention, if you want to try to make your build reproducible, you could also use Maven wrapper, which is just a command line file that you can download, and it will download a Maven version and build your project with the Maven version that was just downloaded. So this is also a way to make it more reproducible. Okay, let's go in and add some more dependencies. So we have a nice project, we have some plugins up here, and now we are looking at some dependencies here, and we got some, no we're not, oh they're up here. We got some Apache Commons Lang 3, so general recommendation, just copy and paste this from every project that you have and include it. Either way, if you need it or not, it's always a good idea to have that in place, right? Okay, no, it's a joke. One time I didn't make it clear that it's a joke. Don't do it. Only use the dependencies that you really need. We have bean utils, we have some microstream going on here, and then we have, of course, for our tests, we have JUnit. And then this is a small project, and we can look at the code and figure out what we really need, okay? So when we look at this, we could read the code, mostly the imports, I guess, and we could somehow make some conclusions what we need and what we don't. Can you tell me what I don't need from the dependencies as added? Okay, you've seen this talk before. Okay. The thing is, this is easy. Okay, this is a small project. And okay, you could do it, but let's be honest. Who has more than, let's say, 5 dependencies in their project? More than 10, 20, 30. Oh my God, I don't know what I'm doing. I have so much dependencies. Okay, I'm honest here, okay? Good, we have some projects like that. Okay, perfect. So there has to be a better way to figure it out than just look at it. And this is where our dependency plugin comes in very handy. And it's not perfect, it cannot do everything, but it can do a lot because it's going to be spring and we need to lose some weight. So let's do this. This is the Maven dependency plugin. We will run this, and this will do static code analysis and look at our code and see where we use which classes that we use and which we don't. And so we have a two-parted result. So we have one part that is used undeclared dependencies. So I'm using something that I did not declare. So let's have a look. Let's have a look at our test class. This is where we use our JUnit stuff. So that's kind of true, because I'm using the JUnit API and I'm using this test annotation here. And what I do in my Maven project is in my Maven POM, I declare engine. So, and we will have a look at this in a second, where you can see that this is wrong. How can we see that? It's not a Maven command, it's called Maven dependency tree, and with that we can see what is actually going on. So just dependency tree. And with that, we get this nice tree. And as you can see, everything that is here in like the first hierarchy, there's a direct dependency. So I'm just saying I need commons long 3, and it has no transitive dependencies. And then bin utils brings me logging, and as we all know, logging is really, really bad, like log4j bad. And then we have collections and some other stuff. And as you can see, I'm saying, hey, I need engine, and engine brings me somewhere here API. So I'm not really being very clear and explicit, so I'm relying on engine to bring me API, and I just use it because it's on the class path and I can use it. So that's wrong. I should specify I want to use API and not engine. Okay? That was the first block. Let's go and look at the second block. Second block says, okay, what you're doing here, you have unused declared dependencies. So I declared I need some dependencies, but I'm not using them in my code, or at least the static code analysis cannot see it. So this is not always perfect, but it's a good way, a good place to start. So the right thing would be to add this dependency and get rid of these two, okay? So we will do that. Then it will look like this. Okay, so long is gone, commons long is gone, this is good. And I have API, and this is a old version of Maven plugins where you still need the engine to run the tests. This is not the case if you have a current version, but in this version you still need this, and I like to use this example to show you how you can deal with it if the static code analysis gets it wrong, which can happen sometime. So what we will do, we will cheat a little bit. So we will say to this dependency plugin, hey, please ignore this one. And please don't have a long list here. You should be very cautious about what you add here, because you defeat the purpose of all the things when you put everything in here. So what we will do, we will run it again. And this is like the thing I like. We get something like no dependency problems found. This is always like, this is gold when you read that. So, you know, you're only using what you need, and we've made the first step to secure our project, because we reduced the attack surface. And sometimes people say, hey, I could have the commons long library, I'm not using it, so it's not a risk for me. So this is not how these attacks usually work. They work in a way where they find some exploit in some library, and then they have what is on the class path. And what is on the class path is always like nice to have, because they have more options to do things. And even though a commons long may not have a vulnerability, another library may have a vulnerability, and they will say, oh, this is nice, I have commons long, so it's less code for me to write, okay? So let's make it harder for them. Okay, so we lost some weight. Is there any Marie Kondo fans? Any Netflix fans from this show? Oh, okay. Thank you for being honest. Perfect. That's good. Okay, it's a nice lady that cleans up houses on Netflix, so yeah. She always says, like, make it spark. You can only keep what makes you spark joy, okay? And you can only keep the dependencies that make you spark joy. So, you're real developers. You like it. Okay, that's good. Okay, so next thing, we have to secure this. And there is an open source variant to secure a project, and we will do an OWASP check. So it will go to a database of vulnerabilities and check if you have something in your project, in this case a dependency, that has a known vulnerability. And when you run this might take a long time because it does some caching and stuff like that. So I did this before the talk to make it fast. And of course, there are better solutions in commercial tools that do more stuff. For example, this only runs when I run the build. So if your project on the weekend, nobody is working on a project and there is a security vulnerability, you will not notice it until the next time this plugin runs. And then it will go to the beta database and look it up, and then it will give you some message or a warning. But there are commercial tools that will tell you on the weekend with a push notification, hey, there is a security vulnerability for something that you use in your project, you might want to fix it, okay? So this can't do this, but this is the open source version, the free version that you can just use here. So, and it tells me that my commons bean utils has a problem and I should fix it. And we get a report for that. I want to show you, this is good because it's part of the paperwork you can do and that you can show to people that they understand there is something to do. So if you have a manager that won't listen, maybe they listen to like HTML documents work better than console. So you get a very elaborate summary of what is going on, what it is called, license and everything, what the problem is, and how to fix it. Usually, and what the problem is, of course, and how to fix it. Usually how to fix it is to get the new version. Usually there is a fix available. If not, there is sometimes a workaround what you can do. When we think back to our log4j problem last year or 2 years ago, there was some, you could just delete one class from this artifact and the problem was fixed if you didn't use that specific class. So could be as easy as that. Okay, so we will go ahead in our pom file and just fix that real quick somewhere here. We will go from version 3 to 0.4 and then we will build it, and then of course we have this nice moment of satisfaction where we can see that this plugin tells us you're doing good, everything is in line, there is no problems with your code or your dependencies. So this is always nice. So this is good. Okay, so it says somewhere here that we are fine. Somewhere. Okay. Good. So we made our build secure. This is very, very good. So we've reached level 4 where we will try to save time and money. Why is it money? Because in the cloud everything costs money, and of course we will save money, and also everything uses CO2 or produces CO2, so we will do something about that too. So let's have a look here. First thing, we will try to understand better what is going on in our build. And there's a build plan plugin, and it has list phase as a goal. And we will run that and get a nice table that gives us a little bit of information what is going on. So this shows us a mapping from the Maven lifecycle phase, in this case here, validate, and what is going on. And this is a one-to-one. This is a one-to-one in my scenario. There could be more plugins running. So in the validate phase, I have the enforcer plugin running, and the goal that runs is enforce. And so you can read that, and in your case, there might be more plugins in one phase. So this is a good place to start to see what is going on in your build. And then we will add an extension to our build. And this is a sneaky way to introduce some security risks, because you can just go in your project directory and create a new file in a folder called .mvn. And in that folder, you can have a file that is called extensions.xml. And in that file, you can specify extensions. So what is the difference between extensions and plugins? The difference is now with extensions, I have access to the class loader where the Maven core is run. So I can profile it, because this is a profiler what I'm adding. But be very cautious. Things that you add here, they can do crazy stuff. So might want to check where you get your stuff from. Okay, and the good thing is I don't have to change anything on the installation of Maven. So I'm not involved with operations again. I just add a file, commit it, and also the build pipeline on my build system, on my remote build system, will also do it, not just on my system, which is great. So with this, I can do just another Maven verify, and I will get in the end a summary of all the plugins and their times, what is going on with them. So I can see I have the validate, which is fast, and then I have a compile. Okay, there was something compiled. And of course, tests took some time. Of course, you can always opt to skip tests. Maybe not. So, and then, okay, I get the summary. And this will help us now to figure out which is the best way to run our build. So if we will do clean verify or just verify or verify install and everything, so we will go through that. Okay, we will start out with Maven clean and install. Okay, this should be, who is doing clean install? Okay, very good, almost everybody. Let's do this. Okay, so here we can see what went on. So clean seems not to be the biggest problem. So 200 milliseconds, then we have compile again, like the same, and then we have install. So this is definitely something that we are adding because when I just do verify, it will not execute the install phase and stop before that. So, okay, why are people complaining about clean and install? So I would say install is not a big problem because it's SSD on my notebook and copying files is not like the big problem that we have. So this is not a problem. And clean is also very fast. So why is that a problem? And I would say it is a problem because it defeats you from getting incremental builds. So my assumption is if I just like stick with install because I like it and it sounds cooler than verify, I will do Maven install, and now the target folder is still there because clean is basically deleting the target folder, and it should be able to reuse my classes because I didn't change my classes, and so it should not compile anything, right? So let's have a look. Here. Oh, yeah. Compile is still going strong. Okay, that's not good. Let's have a look into this. So where is my compile plugin? And there is a compile and a test compile. Okay, so changes detected, recompiling the module, compiling two source files. This seems about right. No, it don't. I have one source file and one test file because the test file is down here. So where is this second file coming from? And again, this is a small project and the numbers are very clear, 1 and 2. If you have a bigger problem, a bigger project, you won't notice that there is another file in your project. And let me find that file. How can we find that file? So we can do something. We can put an X so we get more output, and we run the build again. And in this debug output, we can find where is our problem in the build. I didn't get that joke. Okay. Let me find that real quick, and we will look for the word stale. So this is something you have to know. You have to look for stale, and as you can see, I get a hint here. There's a stale source detected, and what source file detected, and it's called demo2 Java. So let's have a look at this one. What's the problem with this one? Why does it not compile? Okay, have you ever seen a file like this? Okay, this is a main hazard to your build because what is going on? The compiler is looking at your Java file, .java, and looks at your class files, .class, and says, hey, is there something to compile? Yes, there is a file that does not have a corresponding class file. And then the compiler goes ahead and tries to compile. Of course, it looks at the file, sees, okay, there's nothing to compile, there's no class, because I commented out everything, and it's not creating a class file. So the next time, it does it again, and again, and again. So if you want to piss off your colleagues, do that. And they have to spend long hours in the office to figure this out. You know how to figure it out, and the easy thing is just to delete it. So I have deleted this file, it's gone now. So, gone. And I will do it again without the X, so it's faster. So, and we will see if it now works. So it will now go ahead, compile one file, compile one test, which is good. So now we have a state where it had a change. I deleted a file. Okay, now I have a compiled project, and I will compile it or install it again. no changes are made. And now I'm expecting that the compile phase and corresponding files that phases that rely on the compile phase are faster. And they are faster. So this is basically the lookup for a compiler to see if it has work to do. And the build is much faster. And again, if you have 1,000 files, and most of you told me you have monolithic systems, this is a big improvement. And of course, there are plugins that depend on the compile phase. For example, JavaDoc and some other things that you would do when you generate code, something like that. You will only do that if something changed. If nothing changed in the phases before, you don't have to do it. So you can save a lot of time doing that. So to conclude, I would say, install is not a big problem, but calling clean every time might give you a disadvantage and could give you an advantage if you want to have incremental builds and have a faster build on your machine. Okay. This is very good. We've done this. Okay, this is perfect. So we save some time, money, a little bit of the planet. You know how to piss off your colleagues, that's good. And now we will continue on to do some paperwork. And this is like the most fun stuff. We will have to talk to our legal department. I don't know if you have before, but this is always very fun. These people know a lot about jokes and things that I don't like. So we will give them some HTML documents. And there are two plugins that you can call. One is called the project info, and the other is the license plugin. And you can have two very nice documents generated, and we will have a look at them in a second. Okay. First one looks like this. So you get a nice HTML thing that you can give to people with the dependencies that you have, and transitive dependencies and everything, what's going on. And then you've got a dependency graph. And then it's the nice thing, you have licenses. And one funny thing is the Apache license seems not to have like consensus on how to write it. So it's 3 times, I think. It's here, and it's here. It should be the same. But then again, legal will tell you, okay, you might be fine using that. I'm not giving legal advice, by the way. So, but you will talk to your people and they will tell you stuff about this. So having licenses, very great, okay? And then, of course, some nerd stuff, better. You get information about the dependencies that you have and how many classes they have and everything and how big they are. And might be a good thing to see if you can lose some weight in the spring. So I'm guilty myself. Once I brought Guava to a project just to have one hash algorithm, which was very, very stupid because it brought a lot of weight to the project for just one class. So you might want to think about if you want to do something about that. The other one is even better for like legal people because it has like nice, super cool icons. And those icons are a little bit misleading. They say you've got a green check mark if the thing has a license. It does not mean you can use it. It just means there is a license on it. Not having a license on a dependency that you have is usually very, very bad because this is going to jail time for somebody. So, okay, not that good. So, okay, we've done this. We have concluded all the paperwork, which is great. So we can move on and conclude this presentation because this was our level 5. I have one more demo to show, of course. There is, of course, the Maven daemon. So if you are fortunate and work on a Linux system, you can use the Maven daemon, which is a very great project that helps you build even faster. So let's see where I have it. So I run this on a cloud instance in Oracle Cloud, where you can have a really nice free tier. That's why I use that, I have a reproducible environment to do it. So I will do Maven just verify, and this is the way you would do it on your machine without any daemon stuff. And this is a very, 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 very small instance. And it takes a lot of time to build this. So this could be a larger project. And just takes some time. What the Maven daemon does, it uses some optimizations. For example, of course, it starts in the background a daemon, that's why the name, and this spares you of the time to start a JVM for your Maven build. Then it tries to parallelize modules. Usually in the projects that we see, you have a lot of Maven modules, and they can be run in parallel, or as I learned before in the talk of Simon Ritter, they can run concurrent, but maybe also parallel. So, and what you want to do is you want to just add a D here. So everything stays the same, just a D for Maven daemon. And as this is already warm, it's much faster. So this took 2 seconds and something, and the other one took, where is it? Oh, it's gone. Okay. You witness it was very long. So if you want to check that out, that is always a good thing. So the tests is basically the thing that is taking most of the time because they have to run. If you can skip them, you can save some more time. Okay, perfect. So, okay, that's good. And then we have, of course, Maven build cache extension. So this is not to be confused with the Maven repo cache that you have on your machine where you have the dependencies. This build cache allows you to cache steps in your build, for example, compile phase, and then use that cache to be even more efficient. To use that, you have to have Maven 3.9 or Maven 4. Who is on Maven 4, by the way? Yes, thank you. Very good, very good. Because this, now one more thing for performance, I tried different JVMs to run my build. So just my build, not my application, where I run my Maven build. And I've seen that it's a difference on what you use. And many people don't know that IBM has a very nice JVM. It's called OpenJ9. You can download it. It's the same as the other ones, basically, from a user's perspective. But it has some nice optimizations. And on my machine, it's faster using that. So if you want to have faster builds without changing anything in the code, because you can't, because your colleagues, they won't let you, maybe you can profit from it, just use this JVM to run it. It's called OpenJ9, and if you search for it, you will see a term called Simeru. This is how they call their distribution. So it's like Temurin for OpenJDK now, or for the Adaptium. Crazy terms, but yeah, they just want to torture speakers, so they, don't know how to pronounce it. Okay, this is the time to bring out your phones. If you are, if you want to take a picture, if you are very brave, you can scan the QR code and get hacked, or you can just go to my GitHub. Give you another second here. Okay, and now, most important part of this talk. The Maven project is an open source project that is not backed by any company. So this is very rare these days. Usually you have a company and people running around selling stuff. So not for the Maven project. And the Maven project is used by a lot of people, as you can see in this room. So it's done by volunteers. And they need your help. So I'm not coding on the Maven project. I'm just here rigging in some help. So they need help getting it right, because a lot of things depend on the Maven project, that it works and that it's very good backwards compatible. So I would ask you to go after the conference, or maybe in the break, download Maven 4 Alpha. The latest release is 12 these days. Have a look, run your build. It's very easy. It's just a zip file. You download it, you run it with your project and see if it works. You get something back for it. Maven 4 gives you nice warnings about best practices that I talked about in this talk and other things out of the box. So you get help, and it's very actionable. So it's not just something is crazy, but something is crazy in your build, you could do this and that to make it better for you, okay? And this could help also your Maven 3 build. Not everything, but a lot of it. So please do it, give feedback so they can get it right, and we can have a stable Maven 4 version because a lot of us depend on it to do that daily job, okay? Perfect, that's it for for this session. Thanks for being here. I love for you all to connect. We're almost out of time. If you have questions, please find me here at the conference. Find me on Twitter or LinkedIn. Reach out to me. I'm happy to help discuss and talk trash about like Star Wars, because I'm a big Star Trek fan. So, okay, thank you. Thank you. Okay. Who is super eager can stay for 3 minutes of questions. Okay, I already announced you can go. Nice lunch. Hope to see you soon.